I welcome everyone. I started this recording off on a sneeze. I'm sure that'll look good on YouTube. So here's our final session of the SQL series. We're going to talk about case expressions for short bit and then window functions. Here in the chat, I'm going to post the notes for today, which you'll be seeing on my screen. And then, in GitHub in our book club repo, all the links will be there as well. All right, so let me share my screen. And all right, here are our notes. Is this good? Do you guys want me to make it a little bit bigger?
I think it's fine for me.
Okay. All right, so we're going to start off with the case expressions. And basically, I think most of you may have seen this in other languages. It's fairly straightforward, but the main thing is that like a full-on if statement is for control flow. So we haven't talked about it, but like in a stored procedure, you actually can use if statements in SQL, maybe vendor specific, but I know I use them in Microsoft SQL Server. And so you can say, if something is true, then do this query, else do that query. Okay, and so that's choosing between two different queries. But oftentimes what you want is within a query, you want to conditionally have a value. So, the example I give, maybe it's not the most realistic example, but let's just say you're concatenating the first name, the middle name, and the last name. And the first name and the last name are required, so they're never null. But the middle name is optional, and so it could be null. So if you just simply use your vendor's concatenate function in Microsoft, it's just plus, and you say first name plus middle name plus last name, then anybody who has a null middle name, the concatenation of those three is going to be null. You need to deal with that. Now, the reality is there's probably a better like special null handling function that each vendor has, like is null or something like that. But just so you guys understand the concept, so sometimes we want to use the actual middle name, but sometimes we want to use the empty string. So this is the perfect situation for something like a case statement. Okay, so here's an example. I haven't really explained the syntax yet, but if you just read it kind of like plain English, case, when the middle name is not null, then I want you to evaluate as the middle name. Else, if it is null, I want you to evaluate as the empty string, quote, quote. Okay, and then it has an end. So basically that's what case does. So you will see, at least I've seen like, Strata Scratch, LeetCode, these practice problems, where sometimes they'll say like, I don't even know what they'll say, but to just use a silly example, you're returning the name of an animal, and if it begins with an A, I want you to capitalize it, but if it doesn't begin with an A, I don't want you to capitalize it, right? So the only way you can do something like that is you have to have a case statement. And so then, you'd say case, when the animal name begins with an A, and then you can, do your function to uppercase it, whatever, right? Else you can lowercase it, whatever. But I've seen problem after problem where, in my opinion, it's just silliness. They just throw in some wrinkles for no good reason just to make the problem more complicated. But all it really involves is understanding that you're going to have something true, false, and then you're going to return, one value if it's true, and then whatever. All right, so that's my high level explanation, and you can pretty much use a case expression anywhere. Any place where you could have a column name or a constant expression, you can use a case instead. So any questions before I kind of go on to the more formal definition of the syntax and all that kind of stuff? Okay. So here's the syntax. The version I use pretty much all the time is case as a keyword, and then you say when something, when whatever middle name, is null, when animal begins with an A, when whatever price is less than $10. then basically you have the word then, and you have whatever value you want this to evaluate as. And you can have as many whens as you want. You can have 1, you can have 2, you can have 10, you can have 100. Optionally, if none of those whens match, you can have an else at the end that will always evaluate to true, and so then it'll always return this. Only one branch of the case statement can evaluate to true. So if this second one is true, it's going to stop there. It's not going to look at the third, fourth, fifth, whatever. So so theoretically, it would be perfectly valid to say when price is less than 10, and then when price is less than 20, and then when price is less than 30. You don't have to, on the second case, say price is greater than 10 and less than 20, because you already know it failed the first, when branch that said price was less than 10. Okay. The other thing is, in certain languages, there's certain kind of case statements where it can actually follow multiple branches. And so they say, well, if it's 5, then it's going to be both less than 10 and less than 20 and less than 30. Not an issue here. The first branch that it matches, it's going to take that branch and then be done. Okay. There is an alternate syntax. It's fine if you want to use it. You don't have to, because you could always convert it to the other syntax. But if all you want to do is test equality, all right, then you can use some slightly different syntax where you say case and you give it an expression that you're testing for. And then instead of having to say when test expression equals test value 1, you can just skip the test expression equals part. You can just say when test value 1. So for example, you could say case state when, quote, CA, unquote, for California, then this. When, quote, MD, unquote, for Maryland, then that. I don't know if you would do that, but I'm just saying that allows you to just check for a series of values. This could come up, like if you just have a series of numbers, a series of letters, a series of somethings. And like I said, I mean, with very little effort, you could just turn this into the other format by just saying when text expression equals value 1, when text expression equals value 2. But if you like it, you're allowed to use this alternate syntax. And it works almost identically. All right, so let me just see if I got covered the usage stuff. So you can have any number of when branches you want. They're evaluated in order. So the order you type them does matter. And the first one that matches will be the one that's used. You don't have to have the else. And then you can use them pretty much anywhere. So like you can have a case inside of a case. I've certainly done that a handful of times. And just note that case expressions do sometimes wind up in your group by and your order by. So for example, in my example where you concatenate the first name, the middle name, and the last name, if you wanted to group by that name, then you would say group by case blah, 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 or whatever, first name, concatenate case, middle name, concatenate last name. And if you also wanted to sort by that column that you've created, then you would also need that case expression to be in your order by. So for me, it's pretty common that if I'm grouping by something that requires a case statement, in my select list, I'm going to have it, and it's going to be copied and pasted in my group by, and it's also going to be copied and pasted in my order by. That's a relatively common thing. So you shouldn't necessarily feel weird about having one there. Like I've said many times in this series, SQL is a very old language. So the fact that you're copying and pasting the same thing multiple times introduces room for error, copy paste error. If you change one of them and you forget to change one of the other ones, that can cause problems. But it's just an old language, and so that's just the way it works.
Ted, could you use an alias for that then, for the case?
I think I've seen someone use one, but I don't. I don't think it'll work in the group by. It might work in the order by. And the other thing is, if this case expression is your second column, you can also just say order by 2 instead of that case expression. But of course, using numbered positions raises its own problems, because then if you insert a new column into your thing, all of a sudden what was column 2 is now column 3, and you've broken your query and whatever. So basically, I just copy and paste things into the group by and the order by and just live with it. So I see a question about the YouTube channel. So Ryan, if you don't mind, could you post links to the repo and or the repo lists links to the YouTube, but you could also list that directly too. All right. So I just wanted to take a couple minutes to talk about case. Any other questions about these case expressions? All right. So let's get.
I do have just one quick question. The first example you showed, where you say is not null, then so you can do that in SQL. You can say something is this.
No, is null.
Is
null and is not null are specific SQL operators. Okay.
Is null and is not null.
Yes.
Okay.
And actually, I usually capitalize it. So, and then technically, I think you can use not, but anyway. So like, is null is a very special operator in SQL land that will return true if you have a null value. Nothing else will. Anything else you do with a null, it always returns null. You know. So is null greater than something? Is it less than something? Is it equal to null? All of those will not return true. They'll just return null. So the only thing you can do is null. And if you want the reverse of it, you can say is not null. Yeah.
Would that be something that would work in your practice problem that you posted in the chat? Using a case expression for that?
We can certainly take a look at that. I don't think you need a case statement, but there might be a way to solve it using a case statement. Case statement, again, is usually when you want to always return something, but sometimes you want it to be this, sometimes you want it to be that. Okay. If you just want something or not, then usually it's more like the where or the having that's like filtering things out.
Okay.
All right, so let's talk about window functions. I think they're relatively new. So I have a link here. This was also in the meetup description. This is they have like a tiered subscription thing. So if you don't normally read this, then when you go there, it'll say you've got like, you know, whatever, 5 free articles per month, something like that. But this was, I thought, the best article I found just searching around a little bit. And so I picked this over some of the other free articles that were there. So I'm going to flip over to that occasionally if there are questions, because I think they have some nice pictures and things, and I didn't bother to do that. I figured if we have questions, we'll just go to that article for the pictures. But so what is a window function? So I think the easiest way for me to describe a window function is to compare it to the regular aggregation functions that we've already looked at, right? So if you have 20 rows in your query, you can calculate the sum of a particular column in those 20 rows, the average, the min, the max, okay? You could even group by, and so maybe you broke those 20 rows. I don't remember if I said rows last time, but 20 rows. You could break those 20 rows, let's say there happened to be 5 rows each, into 4 different whatever seasons. And so you could say group by season, and then you can calculate the max, min, average, whatever of each of the 5 rows, and you'll get 4 rows back in your results if you say group by season. So what do window functions do differently? They're going to appear in a similar place. Most of the time where you're going to see a window function is in your select list. So just like you might be selecting, you know, the average temperature for spring versus the average temperature for summer or whatever, we're going to do that. But window functions have extra power and flexibility. And the reason why they have that is because regular aggregation functions, when you're doing grouping, okay, they're going to return one value for the entire group. All right. And if you don't have a group by at all, then your entire result set, all 20 rows, is going to return one value. What window functions do is they return a value for every single row. So if you have a 20-row query and you put a window function in your select list, it will return a value for each one of those 20 rows. What's clever about it is that depending on what the function is, it will find the rows that are relevant to that particular row in that you're looking at, and it'll calculate whatever that value is that's most appropriate for the row that you're looking at. This will make more sense in a minute. Okay. And it'll basically it'll give you a particular value, and if you want, those values can be grouped. Okay. But what's cool here is that you get completely separate control, that your window function can have whatever grouping you want, whatever ordering you want, completely independent of your main query. All right, so that's a bunch of words that might not, you know, be the best way. So I sort of interrupted the description of window functions to say, let's just take a look at an example, because it's probably easier if you have something concrete. So in the article, there's a place where they show this particular query. I indented it and you know, cleaned it up a little bit, but this guy right here, okay, it's fairly simple. It's data coming from two tables. There's no where clause, so it's just all the rows once you join those two tables together. Okay, and I believe like the customer ID is coming from the order table, the unit price is coming from the order detail table. But basically, these are two columns that appear if you do this big join. And then we have this thing here, this average unit price, and it says over partitioned by customer ID, and then it just gives it a column name. So we're not really worried about the as part. But so what is happening here is that, let's say you've got 100 rows in your order detail table associated with a certain number of orders. If you just ran this query without this particular line, okay, I just commented that out, then what you would get is you'd get 100 rows and it would just show customer ID and unit price. All right. When I add this line back in, now I'm going to get a third column, but I'm still going to get 100 rows. All right. And in this third column, what it's going to do is it's going to say, I want you to group the information by customer ID. And I want for each customer, I want you to calculate what the average unit price was, you know, for these 100 rows. So basically what it's going to do is it's going to say row one. Oh, row one is an order from customer 10. It's going to find all the rows that are customer 10, and it's going to calculate the average unit price over those rows. Let's say the second order, the second row in our data is an order from customer 17. It's going to go and find all the rows that are customer 17, and it's going to calculate the average unit price over those. Now, if the third row happens to be another order from customer 10, then this calculation of the average unit price is going to be the same number that appeared on the very first row, because they're both customer ID 10. All right, so this is to emphasize the point that it is always going to return a value for each row, but some of them may be duplicated because of just the nature of things. So in this case, this partition by is saying, I want you to do it per customer ID. So if there's 11 orders, all for customer 10, all 11 of those rows are going to clearly have the same average unit price. Okay, so again, if I didn't have this over part at the end, if I just had average unit price, that would be telling SQL Server, I want you to return one row, one single average for all 100 rows. As soon as you say average unit price over, that's telling SQL Server that you want 100 answers, one for every single row in the data. So let me just pause here. Did that make sense? Did I mess anything up in the explanation? Any questions?
It does. I just don't understand why somebody would need it.
Okay, that's good. So we'll get to some examples. All right. So before we get to some more explanations of what are the different window functions and how it makes sense, let me just show you that this same query, let me see if I can fit this on the screen. This same query I could have written, not going to be able to quite fit it on the screen altogether, but I could have written it down here where I have a subquery or a CTE where I calculate, grouped by customer ID, I calculate the average unit price, okay? So however many different customers there are, let's say there's 30 different customers, this subquery is going to return 30 rows, one for each customer, showing what the unit price is for just that customer's orders, okay? If I did this, and I could have written this as a subquery in parentheses, I'm showing it as a CTE because I think it's a little more readable. Then with this CTE, you can see I can tack on an extra join where I took the old query and I join it to my subquery. From there, if I join on customer ID, now I will be able to say, also select the unit price associated with that customer ID. So I didn't need the window function for this particular task. I could have done it, but I do think that, you know, the number of lines of code up here is a lot fewer, and it's avoiding this repetition. You'll see that this subquery has the same from basically as the main query. And so what happened is essentially this part I have in here in yellow, the average unit price in the subquery, that appears at the beginning of our window function. And the group by in our subquery appears in this expression where we change the word group to partition, and it's partition by customer ID. So, so if you understand, oops, trying to scroll a little bit. If you understand what this query is doing, then you will know exactly what that window function was doing, because these two are equivalent. It's just, I do think that the window function, it's a little bit clearer to understand the intent, and it's certainly a little less typing. All right. So having taken a little bit of time to show an example, let me say a little bit more about, well, so what is a window function? Okay. So window functions calculate a value over other rows that are related to the current row. And they're going to use the user specified grouping, and if relevant, the user specified ordering of rows. And it's going to return one value per row in the main result set. So one of the articles that I read said that you can do this cool thing where if you have a group by in your main query, then by using a window function, you can get values that are a result of grouping by something completely different. So that's kind of handy. In addition, if you just even have a normal query, even with say no group bys, you could have a window function that tells you what the average price is per customer, and a different window function that tells you the average price, but grouped by order. And you could have a different one that's the average price grouped by, I don't know, state, by region, okay? And normally, if you want to group by different things, this is going to require a whole bunch of separate subqueries, each with their own separate group by and whatever, and you know, just much more condensed. So that's a little bit of a preview in terms of like, you know, why.
Can I ask a question?
Yeah, please.
So like, is it potentially can be used like in this example, it can be used to calculate the difference between the, you know, the order price, because between the order and an average order, so like,
Mhm.
right?
So you can use an expression. So you could say that my price minus the average price. And so then you could know if this is an above average order or a below average order if it's negative, smaller than the average, right? And there's a whole lot of other things that we can do. Okay. So the key thing is that there's certain things we'll get to the very end that window functions can't do. But window functions always use the same data as the main query. So whatever's in the from and the where clause, it's using that result set. But window functions, you use this keyword partition by, and if you want to use all the data at once, you don't have to. Just like in a regular query, you don't have to use a group by. You can just use the whole thing. But if you want to, you can say partition by, and the syntax is slightly different, but then it'll divide up your data by whatever you say to partition by. So if you say partition by customer, then it'll group all the data by customer. Since they went to the effort of coming up with a brand new keyword, partition by, to replace group by, I personally thought it would have been nice if they came up with a new keyword to replace order by. So they could have just said something like partition by sort by is used by window functions and group by order by is used by main queries, but no, for some reason they just reused order by. So we'll get to some new other functions where sorting matters. If you're doing a sum, it doesn't matter what order you sum them, so you don't specify an order by. But there's other functions where it matters. Okay. So in the end, why is it called a window function? Yeah, I don't know. Basically, window functions, they're kind of smart in that they figure out a set of rows that are related to the current row. So in our example up above, where we said we wanted to group by customer ID, they're finding all the other rows that have the same customer ID. And they're basically creating a little window, which includes your row, but includes a bunch of other rows. And then they're doing some calculation with that window. So that's the best I can come in terms of like an intuitive name. For certain things, you might think of it as like a sliding window, whatever, but that's about as close as I got. And the main thing is that depending on the function, the calculation, that group of related rows is going to be intelligent based on what you want. And so that's really, really useful. The other thing I'll say is that because this is now supported by the actual DBMS, generally speaking, like this query I showed you above, that would do the same thing as that window function. It's generally going to be faster using a window function than if you have your own subquery that calculates the same average or something like that. So here's the full syntax. Well, I don't know if this is the full syntax, but here's the syntax basically where you have the name of the window function. And then generally speaking, the window function, like let's say average, it needs like some column or some expression to tell it what to do. Okay. We'll see that some of the other functions actually have a little bit more going on, but generally speaking, you're going to tell it something that you do. And then you have the special reserved keyword over. Over is what tells SQL that this is a window function. And so optionally, you can have a partition by, which is like a miniature version of group by, but it's group by only for the purpose of this one window function. And then once you get to the next line, then it's gone, right? You can optionally have an order by, which we will need for certain window functions. And then I'm not really going to talk about this, but there is this other third piece that you can put in that's it's rarely used, it's highly advanced. I haven't seen it appear in any practice interview questions, but basically I said that it's smart in that it knows what sort of set of windows are related, like say all the rows with the same customer ID. You can actually tweak that a little bit. You can give it additional instructions to alter, like to maybe filter that window down a little bit, or give it like a max size or something like that. I don't know. I've never actually used that. So we're not really going to talk about this row frame business. That's like super advanced. But so basically, normally you see over open paren, partition by, close paren. Sometimes you see over open paren, partition by, order by, close paren. That's basically what you tack on to a regular aggregation function. All right, so there are three families of window functions. There's the aggregation functions, which are just window versions of the ones you already know. There's nothing much new to know about these. The next thing we'll talk about after that is there's a set of ranking functions. And what these do is if you have a window, these functions describe how does my current row fit or rank within this window. Is it at the top of it? Is it at the bottom of it? Things like that. And then I don't know that there's a good name for it, but relative value functions, what they do is they can actually return a value from a different row. So the most common ones are lead and lag. So imagine if you've done any time series stuff, you can actually say, I'm looking at the price column, but I also want access to the price in the row one above me, or two above me, or below me. And so for certain things, this is just incredibly convenient, and it saves you a bajillion lines of SQL having to try to implement that from scratch. All right, so I have a few notes on aggregation window functions. Again, we just take the regular function and we add the word over, and that tells it that it's an aggregation function. They pretty much work the same way as in regulars. The main difference is that the partition by you specify gives it the grouping. And so that's independent of whatever the main query is doing. So here's an example. I could write a query that lists all the orders for the past month. All right, so let's say all the orders for past month, that's 200 rows. But if I wanted to, I could have a column that says, for each of those 200 rows, tell me how many other orders did that customer have. So the first order is customer 10, and it would say, hey, this customer also, had a total of 11 orders this month. Second row is customer 17, they only had one order this month. I could also say something like, what's the total number of units sold for the particular item on this order? All right, so the first one is grouping by customer, this one is grouping by item. I can group by any number of different things within each window. Excuse me. So does that make sense? Any questions about like how I could take a regular query that returns 200 rows, I could add a window function, it's still going to be 200 rows. I'm not doing any global group by, but that one particular column, what's being calculated, is actually being grouped by whatever I feel like. All right, so then let me just mention, here's something that you cannot do, okay? If I have a query that lists all the orders from the past month, and that's 200 rows, I can't use a window function to tell me how many orders has this customer had in the entire history of the company, okay? Because my main query, the from and the where, is only returning the orders from the last month. I can calculate any kind of function you want on the orders from the last month, but the window function can only see those rows. It's not actually separately going to the database and pulling new data. It's only operating over the same rows as the rest of the query. So does that make sense? That like, that's the one thing, is window functions are not any arbitrary sum or average that you want. It has to be a sum or average on the same exact data that your main query is. All right, any questions about that? All right, so we'll move on, talk about ranking window functions. So what the ranking window functions are going to do is they're going to compare you to the rest of the window and give you information. So common ranking functions include row number, rank, dense rank, and entile, which is like a percentile kind of a function. So basically what these things are doing is they're saying like how early or late, how high or low does each row sit in its window. But the thing is, you can't talk about being the first row out of 10 rows unless you specify how those 10 rows are going to be sorted. So whereas the first group, the aggregation functions, didn't need an order by, all of the rest of these window functions, the ranking functions are going to require an order by. All right. And so let's start with a simple example. You can have a select, and then you can say row number over order by, pick a column or a set of columns, and then the rest of your query. And so then what this query will do is basically the first row in your results is going to have a 1 in the first column. And then the second row will have a 2, and then a 3, and then a 4, all the way to the last row. The nth row is going to have an n in this new row number column. I guess I should probably have given it a name. Okay, so this row number column is going to just have these numbers 1 through whatever. Okay, now which one's going to be number 1? Well, whichever one is first based on this sort order. So if you said order by, last name, then the people with last name A or whatever, they're going to be at the beginning, and then the people with last name Z, beginning with Z, they're going to be at the very end. So I wrote this without any partition by. All right, so it's just numbering the whole result set 1 through n. If I added a partition by, then we could start over again at 1. So if I said partition by, I don't know what's a reasonable partition by, but partition by month, then we're going to get 12 number 1s, because January is going to have a 1, and then when you get to the last of the January results, February is going to start at 1 again, and then when you get to March, then it's going to start at 1 again. And you don't have to have the same number of rows in each month. That's perfectly okay. It's just going to start numbering at 1 every time it gets to a new value for whatever you said you wanted to partition by. Most of the time, if I'm doing order by whatever last name, then my main query, I'm also doing order by last name. So then you actually literally see the results come out on your screen as 1, 2, 3, 4, 5. But technically speaking, you don't have to. It's a little bit weird. But if they don't match, then like if you said you wanted your row numbers to be ordered by last name, but you actually ordered the data, let's say by first name, then it's going to look kind of jumbled, but it'll still be that the person whose last name begins with A will have a row number 1, and the person whose last name begins with Z will have the highest row number. It will still be accurate. It's just you're not showing them in the same order. So that is legit. It's not as common, but that's perfectly reasonable. Okay. Any questions about the row number example? All right, stop me if you guys have any questions. So there's some other functions. So for example, the rank and the dense rank functions are similar to row number, except that they understand the concept of ties. All right, so let's say that these are the column that we're looking at is the times for some kind of race. Okay, so if the first person finished in 5 minutes and the second person finished in 6 minutes, and the third person also finished in 6 minutes, then basically you have a tie for second. And the rank and the dense rank functions understand that. So the only difference is that if you use the rank function, you'll have the first person and then the second person will get a 2. They were in second place. And then the next person is going to say that they were in 4th place. There will be no 3 because there were 2 people tied for second place. I think like if I watch something like a golf tournament, golf, like people have very similar scores, right? So if you have a couple people tied, then they skip over the next place. And so basically, these people would split the second and third place prize money, and then the next person's going to get the 4th place prize money. Occasionally you don't want that, and so then dense rank does the opposite. It doesn't skip any numbers. You'll get 1, 2, 2, 3, etc. So when you use rank and you look at the last person, assuming that there's no ties in the last place, that equals the total number of people. But when you use dense rank, if you have ties, then actually whatever the last number is could be quite a bit less than the total number of people, because it's really just, you know, glomping people together when there are ties. The Untile function works similarly, but instead of giving you just an integer like a 1, 2, 3, whatever, it's telling you what the I'll just say percentile for now. It's telling you what the percentile is. So a number between, like, you know, 1 and 99 or whatever. The reason why it's called Untile is because it doesn't just do percentiles. It can do anything you want. So if you give it a 4, it'll do quartiles. If you give it a 5, it'll do quintiles. If you give it a 10, it'll do deciles. And it's only when you give it 100 as its parameter, then it does percentiles. So it'll do any kind of whatever, quartiles, deciles, percentiles. That's why it's called the generic name N-tile. All right, so these are the rank functions. Rank functions, I say I would use them. I use row number a lot. Sometimes I just want my darn output with numbers because it's easy for people to read, you know? So if you spit something out and they just see 1, 2, 3, 4, it just makes it a lot easier. I don't know, there's other reasons, again, why I just want to see stuff numbered. It comes up from time to time. Rank, less so, but yeah, sometimes I use it.
Is the syntax, I haven't used this that much, but from what I remember, the syntax could vary depending on what SQL you're using, right?
Not sure, because like for work, I do all my stuff with Microsoft, so I really know the Microsoft syntax, and I don't know if Oracle's different. But like here, row number is always going to do 1, 2, 3, 4, 5, 6, 7. It doesn't need any additional information. If you say rank, then over here, you would need to give the column name. Okay, so I want to know the rank of, you know, your finish time, you know, and then basically you could say well, I mean, for my example of a race, you would order by finish time as well, but it does not have to be that way. There's I don't know if I can think of a good example, but for example, I do medical claims, and so sometimes you have multiple lines for given claims. Some claims are only 1 line, some claims could be 20, 30 or whatever. And it is really handy to then say, I'm going to do a row number and I'm going to partition by claim ID. So for every claim, I want to start at 1 all over again. And if this claim only has 1 line, then it just gets a 1. But if it's 23, then it's going to number them 1, 2, 3, 5, 6, 7. And then I have to figure out what the sorting is. So by what criteria am I going to say this one's first, this one's last?
So the over, so partition by is kind of like group by, right?
It is exactly like group by. It's just a mini group by that only operates for this one particular window function that you're doing right then and there. Yep. Any other questions? All right, let's talk about this last category then. So not a really good name for this last category. I called it relative value, but in different write-ups, you'll see different names for it. But if I give you examples of these functions, it's a lot more obvious than trying to give it a darn category name. So the most common ones here are lead, lag, first value, and last value. Okay, so once again, the idea of wanting to know the value of a particular column in the row that came immediately before mine, you have to have a sense of how did you order the rows to know that this one was before or after. You have to have a sort order for all of these functions. So here's an example. Imagine you're doing a time series analysis of daily stock prices. And so you have a column called close date. That's like, tells you what day you're looking at, okay? And you have a column called price. So if I have a query and I say select price, that is just going to tell me what the price is for that given day. If I say lag of price, and I'm doing it ordered by close date, then what this will do is this will tell me what yesterday's price was. If I say lag price, comma 2, order by close date, then this will tell me what the price was 2 days ago. That's a very common thing that you do in time series. Theoretically, you can do lead, you can say what's tomorrow's price, but if you guys do time series problems, you know, you're very often computing lags and things like that. So this is a huge pain in the neck to get yesterday's price, not just once, but for every single row to show what yesterday's price was is a huge pain in the neck if you don't have any window functions. It's just god awful ugly. So every now and then when you want to do something kind of iterative, sometimes window functions come to the rescue, because for example, if you number the rows 1 through n, then sometimes you can do certain operations based on the fact that they're a particular row number. You know, you could even do things like you could join a particular something that's row whatever to something else where it's like row -1, if you wanted to somehow like shift things, offset things by 1 or something like that. So there's a lot of stuff that you could do, but many times you don't need to do those because the window functions can do all these fancy things, you know, for you. So for example, lag and lead, they do that where they can offset, you know, up or down however you want. And then the first value and last value, I haven't ever had occasion to use them, but you could imagine that if somehow the first row was always special or the last row was always special, then so in my work, I would say I probably just use lag and not the other ones. And so I think I've talked about in previous examples, imagine you have a race and you have everybody's times, and I asked you to say for each person, how much did they beat the next person by? That is a huge pain in the neck query to write without window functions. With window functions, it's trivial. You basically just say, you know, my row's time minus lag, you know, the next person's time. And, you know, with about 10 extra characters, now you have how much, what's the difference between your time and the next person having?
Can I ask a question?
Yeah.
So could we use lag, for example, if we wanted to know, so an example that's not time series based is if we wanted to know maybe the person who made the second highest sales, and then we had the data ordered by sales.
Normally when I want, so remember, lag is going to give you something relative for every single row.
Oh,
Okay. If I want the second person, normally what I do is I just do row number, and then I say where row number equals 2.
Okay.
Okay. Sometimes you can do it in one quick query. Sometimes you need to have like a subquery or CTE where you pre-process and add the row number. And then once you have the row numbers, then it's really easy to do stuff. Okay. It just kind of depends on the circumstance. But these are exactly the kinds of things. So when you want just one thing, the second person, that's probably the way I would do it. But if, and you can also say the second person partition by whatever, and for every single department, you can grab the second person, right? You can still do that. But lag is really where for every single row, you want to know the person who's 2 before them.
Okay,
That would be more the situation.
thank you.
Yeah, I see a hand raised. Go ahead, Emil.
Yeah, I just wanted to mention, like, so we use occasionally, or I mean, we sometimes use that product that's like sort of old. It's called Hyperion Brio. I think it's Oracle based, and so Hyperion Intelligence Explorer is basically you can do like a lot of. I mean, I use the lag or lag function primarily. I think in that product to deduplicate data. So let's say I have the multiple rows, and that product allows you to do kind of aggregate functions like say sum, like let's say sum of the amount of the orders, right? But it basically produces the way that it works. It produces multiple rows, like it's kind of similar to the Windows function. But in the end product, in the end result, I really want to have just one row. So I use that lag function to unduplicate. Although it's kind of called differently, I think it's called prior and like prior or something. So I use like comparing prior to the current row. So when I compare, let's say that ID of the customer, I will compare prior to the following. And if it's matching, then I exclude that. And if it doesn't, that's the unique row that I want to keep. So I then filter it down to that only that lines.
Yeah,
basically
cool.
duplicating data.
Yeah, cool. By the way, I've done that like exact same thing in Excel sometimes. I've got a bunch of stuff and like it'll be, John, and then after some number of repetitions, it'll be Mary, right? And so I just want to know where a new person starts. And so I basically check to see if the row above me is the same value as mine. And if it's different, then that means I'm starting a new name right here, right? Yeah, so you can definitely compare yourself to the previous row. I don't think it's any faster, any slower, any better. What I would tend to do is I would use row number, and I would just number all the Johns, number all the Marys, and then I would say, grab all the rows where row number equals 1. And so then it's only going to grab 1 for John, 1 for Mary, 1 for whatever. Depending on like what kind of thing you're doing. Sometimes you can do a group by or a distinct or whatever, but yeah, there are cases where I can't. And so what I end up doing is kind of what you're talking about, either compare or so sometimes there's different window functions you can do that will kind of, multiple ways to kind of get at the same thing. I did want to mention one thing that I have done and people often do is they use the regular aggregation functions to do like running sums and that kind of stuff. So for some reason, I'm just blanking on like the situation where you want to know the running sum. But basically, if the first person ordered $5, second person ordered $3, the next person ordered $10, and you just wanted running sums where like for the first row, it's 5, and then it's 5 plus 3, it's 8, and then it's 5 plus 3 plus 10, it's 18. And you just wanted to keep building this up. So the grand total will obviously be the total at the very end, but you wanted all those intermediate running sums. You can do a sum over order by, and it'll calculate a nice running sum for you in about 15 characters. So I'm blanking on when I've done it, but I have wanted running sums. And so it's nice to be able to do it. And if you want it grouped by whatever, you can also say sum over partition by this, which means you're going to start at 0 again every time you get to a new value for your grouping column, and then again order by whatever, and you get these nice pretty running sums. Yeah, cumulative sum, running sum, whatever name people go by. Okay, so again, I wanted to emphasize that window functions always operate on the same data as the main query. So in that example before, if you have 1 month of data, you cannot have a window function that figures out some average of a year's worth of data. It's only going to be able to work with the data in your main query. Now, technically speaking, if you're really clever, you could write a main query that has a year's worth of data and only report on some subset of it by like using a case statement and nulling out some of the rows or whatever. And so you can be clever about that, but just on the surface, the window function is always operating over the same set of rows as the main query. And then, you know, in my opinion, you can do most of the things, if not all, without window functions, but subqueries and the self joins can get really, really ugly. And so, you know, window functions, if you see lag rather than some monstrous, weird subquery self join kind of a thing, it's kind of intuitive, like, oh, lag, you just want the value from the previous row or however many rows ago, you know. And same thing for a lot of these other things. It's just like, oh, you know, if you want to know, like, am I, you know, the median? Well, if you're the 50th percentile, then yes, you're the median. You know, it's just, it's a little bit more intuitive. All right, so that's the main content for today. I think maybe what we'll do is we'll stop the recording here, and then I am flexible. I can